Hi everybody, and welcome to exercise 1 on page 35 of the workbook. And we're going to look at part A of this exercise. This is a long list of exercises that all deal with this diagram that we're looking at over here to the right. Right? So in part A, we're focusing on the region R1, okay? And I'm just going to kind of highlight it. So it's the region that lies between the curves that I'm kind of tracing out. And they'd like us to rotate that curve about the y-axis and set up an integral that would give us the volume of that solid of revolution. Okay, so let's start with a picture by just trying to draw our best picture of the volume that we're talking about. So let's see, I'm going to put that down here. And I'm just going to redraw R1 as best as I can. So it kind of looks like we've got this curve here. Okay, and we'd like to take that region and rotate it about the y-axis. Okay, so our axis of rotation is sitting here. So imagine taking that region that we just drew and drawing its mirror image through the y-axis. And we're going to get something that looks like that. Okay, can you picture that solid that we're talking about? It's a little bit challenging. I always feel like somebody's giving me one of those psychological tests where they say, look at a picture and what do you see, Jerry? Well, I'm seeing maybe a tornado or something like that. Maybe you're seeing something different. Okay, so it's sort of a solid shape. There's no gap in it in this case. And the thing to always remember is we want to slice perpendicular to the axis of rotation. So if this is our axis of rotation, we're going to take out our machete and slice this way. Okay, and if you do that, you're going to get a slice without a hole in it. Again, we mentioned that this is sort of a solid shape that we're looking at. And the key to writing down a volume integral is to figure out what the area of that slice is. Okay, so let's draw a top view here. Okay, so to find the area of that slice, we need to know what its radius is. Okay, so here comes another very important question that you always want to ask yourself when you're doing a problem like this. Is the radius that we're drawing a vertical or a horizontal distance? Is it vertical or is it horizontal? Well, notice that it's horizontal. We're going left to right, and that tells us that what we're interested in knowing is x values here. We need to know what x is equal to on both sides. That's how we're going to measure a horizontal distance. Okay, well, from the picture, you can probably see what the x value is over here. It's 0 because we're right on the y-axis. What about the x value on the right-hand side over here? Okay, well there, what's important to know is the equation of the curve. Okay, and from the picture, going back up to the picture, that's the curve that's labeled y equals x to the 1/3. Okay, how do we solve that for x? Well, we would just cube both sides and get x equals y cubed. That tells us the answer to the question that we asked. Okay, the x here is just going to be y cubed. Okay, so finally, we have enough information then to measure this radius left to right. It's just going to be the difference between the x values, y cubed minus 0, okay, or just y cubed. All right, so the volume then that we're looking for should be the integral of the area of that slice, okay, pi times the radius squared times dy. Okay, let me clear a little bit of clutter out of the way here. Okay, and what's missing from our integral are limits of integration. Okay, should our limits be x values or y values in this case? Well, there's what's going to answer that question for us. We've got y's in our integral, so we should have y values. So you want to kind of ask yourself, if you look at your region from bottom to top, where do we start and where do we stop? Okay, so the bottom of our region is down here and the top is up here. You can kind of see from the picture that that's y equals 0 and y equals 2. So those should be our limits of integration. Okay, And they told us to just set up the integral and not evaluate it, so we're essentially done. I'm going to do one simplification here and just write this as the integral of pi times y to the sixth. If we take y cubed and square it, we're going to get y to the sixth. Okay, and there's our answer.